Welcome back to Fact Fusion Network. Today, we're diving into one of the most mind-bending topics in physics, quantum behavior. This is the realm of science that governs the tiniest particles in the universe, like electrons, photons, and atoms. It's a world where the rules we're used to simply don't apply. So, buckle up and get ready to explore the strange and fascinating world of quantum mechanics. What is quantum behavior? Let's start with the basics. What exactly is quantum behavior? In classical physics, the physics of the everyday world, we can predict the motion of objects pretty easily. For example, we know where a car is going if we know its speed and direction. But in the quantum world, things get, well, weird. Quantum behavior refers to how particles, like electrons and photons, behave at the microscopic level. At this scale, particles don't follow the neat, predictable paths like planets around the sun. Instead, they exist in a state of superposition, meaning they can be in multiple places or states at the same time. The wave-particle duality. One of the strangest aspects of quantum behavior is something called wave-particle duality. This means that particles can behave like both waves and particles. Imagine light. It travels in waves, right? But at the quantum level, light also acts like a particle, which we call a photon. It's not just light, though. Electrons and even atoms exhibit this wave-particle duality. Take the double-slit experiment, for example. When we fire particles, like electrons, through two slits, they don't just create two lines on the screen behind them. Instead, they create a pattern of light and dark bands, just like waves in water would. This suggests that the particles are interfering with themselves, behaving as if they're passing through both slits at the same time. Superposition, a particle in multiple states. Now, let's talk about one of the most famous phenomena in quantum mechanics, superposition. In the quantum world, particles don't have definite positions like you and I do. Instead, they exist in a cloud of probabilities, and only when we measure them do they collapse into one specific state. To make that clearer, think of Schrödinger's cat. This thought experiment imagines a cat in a box with a quantum particle. As long as the box is closed, the cat is both alive and dead at the same time because we don't know the state of the particle inside. Only when we open the box do we find out whether the cat is alive or not. This is a metaphor for quantum superposition. Particles can exist in multiple states until observed. Quantum entanglement, spooky action at a distance. Quantum entanglement is another mind-boggling concept. Einstein famously called this spooky action at a distance. Here's how it works. When two particles become entangled, their properties become linked, no matter how far apart they are. If you measure the state of one particle, the other instantly knows and adjusts its state accordingly, even if they're light years apart. This challenges everything we know about the speed of information and light. How can one particle instantaneously communicate with another across the universe? Well, that's one of the mysteries scientists are still trying to unravel. Quantum tunneling, passing through barriers. Finally, we have quantum tunneling. In the classical world, if you hit a wall, you stop, right? But at the quantum level, particles can sometimes pass through barriers as if they weren't there. This phenomenon is called quantum tunneling. It's a bit like a ghost walking through walls, impossible in our everyday world, but quite common in the quantum realm. Quantum tunneling is actually a key process in many technologies, including the chips in our computers and even nuclear fusion in stars. The future of quantum mechanics. So, why should you care about quantum behavior? Well, quantum mechanics is already changing our world. Quantum computers, which use superposition and entanglement, promise to revolutionize computing power, solving problems that are impossible for today's computers. Quantum cryptography is creating ultra-secure communication channels. The future is quantum, and we're only scratching the surface. Quantum behavior may be strange, but it's the key to understanding the universe at its most fundamental level. Thanks for joining us today as we explored the mysteries of the quantum world. If you enjoyed this video, don't forget to like, share, and subscribe to Fact Fusion Network for more fascinating insights into the world of science and technology. See you next time.